Why do we have these weird structures that no one can really explain? And when you think about the fact that there's so much evidence that we were hit by comets, that we were hit by large objects. Like, I didn't know about that enormous crater that's in Antarctica.
Antarctica, just saying the name conjures images of endless white, biting cold and, well, mostly just ice, right? A desolate, frozen wasteland at the bottom of the world. That's the picture we're usually given. But what if that picture is radically incomplete? What if the reality hidden beneath miles of ice or tucked away in its vast, unexplored corners is far stranger, more dynamic, and even more mysterious than we commonly believe? Scientists are continuously making discoveries there that challenge our perception of this continent.
Look at a part of the planet we have never seen before. Giant piece of ice broke off from an Antarctic ice shelf, revealing an ecosystem on the seafloor that has never been accessible to humans. What scientists found was both stunning and surprising, proving that life exists under astonishing conditions.
It seems Antarctica is definitely not what we've been told. Stick around as we uncover some of the most intriguing, baffling, and sometimes downright terrifying facts emerging from the ice. So let's start by peeling back that icy layer. For decades, we mapped Antarctica's surface, assuming the land underneath was likely flat, ground down by the immense weight of the ice sheet. Then came technologies like ice-penetrating radar and everything changed. Imagine flying over a seemingly endless, flat expanse of white, but your instruments are painting a picture of something impossible beneath you, a massive mountain range as large as the European Alps completely buried under 2 miles of solid ice. These are the Gamburtsev Mountains. Discovered back in the 1950s by a Soviet expedition, their sheer existence was baffling. How could such jagged peaks survive millennia of glacial grinding? We now believe they were uplifted relatively recently, geologically speaking, before the ice sheet fully formed, preserving their structure like a time capsule. They remain one of the least understood mountain ranges on Earth simply because they are so inaccessible. But the mountains are just the beginning of the subglacial secrets. Beneath that same colossal ice sheet, scientists have discovered a network of over 400 lakes. Yes, liquid water, kept from freezing by the immense pressure from the ice above and geothermal heat from the Earth below. The most famous of these is Lake Vostok, one of the largest lakes on the planet, comparable in surface area to Lake Ontario, buried under nearly 2.5 miles of ice. Think about that, a body of water potentially isolated from the outside world for millions of years. Drilling projects conducted with extreme caution to avoid contamination have reached its surface, bringing back samples containing microbial life, organisms that have evolved in complete darkness, under crushing pressure, in near-freezing water. It's an environment unlike almost anywhere else on Earth, a potential analog for icy moons like Europa or Enceladus. What other secrets, what other forms of life or geological structures lie hidden in Vostok and the hundreds of other subglacial lakes we're still just beginning to map? The scale of this hidden world beneath the ice is staggering, hinting that the Antarctica we see is just the tip of the iceberg, quite literally. But these hidden landscapes weren't always entombed in ice. What if this continent, now the definition of frozen, once hosted thriving green ecosystems? It sounds like science fiction, doesn't it? Palm trees swaying in Antarctic breezes. But the scientific evidence is undeniable. Antarctica wasn't always the polar desert it is today. Thanks to the slow dance of continental drift, it spent millions of years in more temperate latitudes. And during warmer periods in Earth's history, like the Cretaceous period when dinosaurs roamed, or the Eocene epoch around 50 million years ago, Antarctica was a vastly different place. We know this because scientists keep finding the proof: fossils. Imagine paleontologists bundled against the fierce polar wind chipping away at rock on Seymour Island off the Antarctic peninsula. They aren't just finding hardy lichens, they're uncovering fossilized leaves of beech trees at Nothofagus, relatives of trees found today in South America and Australia. They've found fossilized pollen from palm trees and relatives of baobab trees. During the Eocene, parts of Antarctica likely experienced a climate similar to modern-day New Zealand or Patagonia, cool, temperate rainforests. Drill cores taken from the seabed off the coast have recovered ancient soil layers packed with pollen and spores from a diverse range of plants, painting a picture of a forested continent with flowing rivers. And it wasn't just plants. Fossil evidence points to a surprising array of animal life. Remains of large amphibians, reptiles, and even dinosaurs have been discovered, including species unique to the continent. Later, during warmer Cenozoic periods, early mammals roamed this land. Fossils of marsupials similar to those found in Australia and South America, remember Gondwana, and even strange hoofed mammals called ungulates have turned up. There's even evidence of giant Cenozoic birds, including formidable terror birds, apex predators of their time. These discoveries fundamentally change our view of Antarctica. It wasn't just a passive block of land drifting south, it was a living, breathing ecosystem, part of the interconnected web of life on Earth, hosting unique species and participating in global climate shifts. The ice that covers it today is merely the latest chapter in a long and surprisingly dynamic history. Finding remnants of this lost green world buried under the ice or exposed in rare ice-free areas really makes you wonder what other chapters of Earth's history are locked away down there. Discovering ancient forests is one thing, but surely nothing much can actually live there now, right? Apart from penguins and seals on the coast. Well, the surprises don't stop with the past. When we think of life in Antarctica, it's usually penguins huddled together, seals lounging on ice floes, maybe some hardy mosses in the slightly less harsh peninsula region. But the true story of Antarctic life is far weirder and more resilient. The continent is a laboratory for life pushed to its absolute limits, extremophils, organisms that thrive in conditions that would kill almost anything else. We already touched on the subglacial lakes like Vostok. The microbes found there are fascinating. They survive in perpetual darkness under hundreds of atmospheres of pressure, with incredibly limited nutrients, possibly metabolizing minerals from the underlying rock or utilizing chemical energy sources rather than sunlight. Studying them isn't just about understanding Antarctic biodiversity, it's about understanding the fundamental limits of life itself and the potential for life to exist in similar environments elsewhere in the solar system. Are these microbes ancient relics trapped for millennia or part of a more dynamic, interconnected subglacial ecosystem? We're still figuring that out. Then there are the McMurdo Dry Valleys. These are some of the most extreme deserts on Earth. Incredibly cold, incredibly dry, and relentlessly scoured by wind. They look almost Martian. Yet even here, life clings on in unexpected niches. Scientists have discovered cryptoendolithic ecosystems, communities of algae, fungi, and bacteria living inside porous rocks. The rock itself provides shelter from the wind and UV radiation and traps tiny amounts of moisture. It's a hidden world within the stone, and beneath the ice shelves in the deep, dark ocean, other surprises await. Near volcanic vents on the seafloor, unique communities can form similar to hydrothermal vent ecosystems found elsewhere, relying on chemosynthesis rather than photosynthesis. While large-scale vent fields like those in the Pacific haven't been found directly under the main Antarctic ice sheet yet, the potential is there given the known subglacial volcanism we'll discuss shortly. Already, exploration beneath the Ross ice shelf using remotely operated vehicles has revealed surprisingly complex communities of sponges, anemones, and other filter feeders clinging to the seabed in total darkness miles from the open ocean. How do they survive? What do they eat? These discoveries constantly force us to rethink where life can exist and how ecosystems function in the most extreme places on our planet. Antarctica isn't barren, it's just incredibly selective about what kind of life thrives there, often in ways we're only beginning to appreciate. Life thriving in cold darkness is bizarre enough. But what about the opposite element, intense heat, right in the heart of the Ice Kingdom? Ice and fire seem like polar opposites, pardon the pun. You don't typically associate the coldest place on Earth with active volcanoes, yet Antarctica is geologically active, and its volcanic nature plays a crucial, often hidden role in shaping the continent and its ice sheet. Perhaps the most famous symbol of this fiery heart is Mount Erebus, the southernmost active volcano on Earth. Located on Ross Island, Erebus is remarkable for its persistent, convecting phonolite lava lake, one of only a few such lakes in the world. Imagine standing near the summit peering into a crater filled with molten rock while surrounded by glaciers and temperatures far below freezing. Erebus constantly releases plumes of gas and occasionally ejects volcanic bombs, a dramatic reminder of the heat lurking beneath the ice. But Erebus is just the most visible example. Scientific surveys, particularly using radar and seismic imaging, have revealed that Antarctica hides potentially the largest volcanic region on Earth under the West Antarctic ice sheet. Over 130 volcanoes, perhaps even more, have been identified beneath the ice concentrated along the West Antarctic Rift System, a major geological fault zone where the Earth's crust is being stretched thin. While most of these are currently dormant, nobody knows for sure if or when some might erupt. A major subglacial eruption could have dramatic consequences, melting vast quantities of ice from below, lubricating the base of the ice sheet, and potentially accelerating ice flow towards the sea. Even without full-blown eruptions, the geothermal heat radiating from these volcanic areas and the rift system itself significantly influences the ice sheet. This heat contributes to the existence of subglacial lakes and rivers, creating pathways for water to flow beneath the ice, affecting how the glaciers move and drain. It's a factor that climate models are only beginning to incorporate accurately when predicting future sea level rise. So far from being a geologically dead block of ice, Antarctica simmers with hidden volcanic activity. This internal heat adds another layer of complexity and dynamism to the continent, proving again that there's much more going on beneath the surface than meets the eye. Mountains, ancient forests, strange life, and hidden volcanoes. Antarctica seems determined to defy expectations, and its weirdness doesn't stop there. The continent boasts some truly bizarre natural phenomena found nowhere else. Antarctica isn't just extreme, it's downright strange sometimes. The continent hosts natural phenomena that look like they belong on another planet, born from its unique combination of cold, ice, and geology. One of the most visually arresting examples is bloodfalls. Flowing out from the tongue of the Taylor Glacier in the McMurdo Dry Valleys is a plume of brine vividly colored like, well, blood. For decades, its origin was a mystery. Early explorers thought red algae were responsible, but the truth is stranger. The source is a subglacial pool of ancient seawater trapped when the glacier advanced, perhaps millions of years ago. This brine is incredibly salty, several times saltier than seawater, which prevents it from freezing even at Antarctic temperatures. Crucially, it's also rich in iron dissolved directly from the underlying bedrock. Because it's been sealed off from the atmosphere for so long, this iron is in its ferrous state, Fe2+. When the brine eventually seeps out through fissures in the glacier and hits the air, the iron rapidly oxidizes. Essentially, it rusts, turning the water a shocking blood-red color, forming ferric hydroxide, FeOH3. Bloodfalls isn't just a creepy spectacle, it's a unique window into a hidden subglacial aquatic environment and its geochemistry, supporting a microbial ecosystem cut off from the world. And then there are the winds. Antarctica is home to the strongest, most persistent winds on Earth, katabatic winds. These aren't ordinary storm winds, they are driven by gravity. Cold, dense air accumulating over the high polar plateau starts to flow downhill towards the coast, accelerating dramatically through glacial valleys. Coastal stations have recorded gusts exceeding 200 miles per hour, 320 kilometers per hour. These relentless winds sculpt the snow surface into bizarre shapes called sastrugi, sharp, irregular ridges and grooves that make surface travel incredibly difficult. They can also create dramatic visual effects like snow devils and blowing snow that reduces visibility to 0 in seconds. You don't just hear these winds, you feel them in your bones. Early explorers wrote terrifying accounts of being pinned down for days by winds that threatened to rip their tents apart, and the ice itself takes on strange forms. In the high-altitude, dry regions, sunlight can sublimate ice directly into vapor, carving out fields of tall, thin ice pinnacles called penitentes, looking like armies of kneeling figures cloaked in white. Antarctica also plays host to unique atmospheric phenomena, from incredible auroras, the aurora australis, dancing in the polar night, to complex halos and sundogs created by ice crystals in the air. It's a place where the fundamental forces of nature, cold, wind, ice, and geology, interact in extreme ways to produce sights and conditions unlike anywhere else. This unique environment, hostile as it is, actually makes Antarctica incredibly valuable for looking far beyond our own planet. How can the coldest place on Earth help us study the hottest events in the universe? It might seem counterintuitive, but the vast, stable, and incredibly clear ice sheet of Antarctica makes it one of the best places on Earth to observe the cosmos, particularly elusive particles from space. The continent has become a giant natural laboratory for physicists and astronomers. The prime example is the IceCube Neutrino Observatory located at the South Pole. Neutrinos are fundamental particles often called ghost particles because they have almost no mass and interact very weakly with matter. Trillions of them pass through your body every second without you noticing. They travel across the universe from extreme cosmic events, exploding stars, supernovae, gamma-ray bursts, the regions around supermassive black holes, carrying information directly from the heart of these cataclysms. But they are incredibly hard to detect. That's where the Antarctic ice comes in. IceCube uses a cubic kilometer of deep, exceptionally clear Antarctic ice as its detector. Thousands of optical sensors called digital optical modules, or DOMs, are embedded on strings lowered into holes drilled down to 2.5 kilometers deep. When a high-energy neutrino very rarely happens to interact with an atomic nucleus in the ice, it produces secondary charge particles that travel faster than light in ice, though not faster than light in a vacuum. This creates a shockwave of blue light called Cherenkov radiation, like an optical sonic boom. The DOMs detect this faint flash of light, and by analyzing the timing and pattern of the light hitting different sensors, scientists can reconstruct the neutrino's direction and energy, pointing back to its cosmic source. IceCube has detected the first high-energy astrophysical neutrinos, opening a new window onto the high-energy universe. Antarctica's deep, dark, transparent ice is the key. Beyond neutrinos, the stable ice sheet and dry atmosphere are also ideal for other types of cosmic observation. Experiments search for cosmic rays, high-energy particles from space, and study the cosmic microwave background, the faint afterglow of the Big Bang. Furthermore, the continent is covered in seismometers, primarily to study earthquakes and the Earth's interior. But these instruments also provide invaluable data about the ice itself, detecting icequakes, tracking the movement of glaciers, mapping the bedrock topography, and even potentially listening for the rumbles of subglacial volcanic activity. Antarctica, therefore, isn't just a subject of study, it's a platform, a giant instrument allowing us to probe both the Earth beneath our feet and the farthest reaches of the universe. Given all these incredible scientific discoveries and the potential for more, you might wonder why the continent seems so guarded, almost locked down. Talk about Antarctica often drifts into whispers of restricted areas, no-fly zones, and military secrecy, fueling speculation about what governments might be hiding there. While the reality is less conspiratorial, the way Antarctica is governed does contribute to its air of mystery. The continent isn't owned by any single nation. Instead, it's managed under the Antarctic Treaty System, a remarkable international agreement signed in 1959. The core principles of the treaty are peace and science. It designates Antarctica as a natural reserve devoted exclusively to peaceful purposes. Military activities are banned, as is nuclear testing or disposal of radioactive waste. Freedom of scientific investigation and cooperation are enshrined as key goals. This treaty has been remarkably successful in preventing conflict and fostering international collaboration in a unique geopolitical space. However, part of protecting this fragile environment and the sensitive scientific work conducted there involves careful management and, yes, restrictions. The treaty system allows for the designation of Antarctic specially protected areas. ASPAERs and Antarctic Specially Managed Areas, SMAs. ASPAERs are created to protect outstanding environmental, scientific, historic, aesthetic, or wilderness values or ongoing research. Entry into an ASPAER requires a special permit granted only for compelling scientific or management reasons that cannot be served elsewhere, and activities are strictly regulated to minimize impact. Think of areas with unique ecosystems like those dry valley endolithic communities, important penguin breeding colonies, or sites of long-term monitoring. ASMAs are larger areas where activities are managed to avoid conflicts and minimize cumulative environmental impacts. So, are these zones hiding alien bases or ancient pyramids? Almost certainly not. The restrictions are primarily driven by genuine needs, protecting incredibly fragile ecosystems from contamination or disturbance. Even footprints can last for decades in some areas, ensuring the integrity of sensitive scientific experiments like the ultra-clean drilling at Lake Vostok or the low background noise needed for cosmic ray detectors, and basic safety in an environment where rescue is incredibly difficult and expensive. However, the sheer scale of the continent, combined with these necessary access controls and the inherent difficulty of operating there, means vast areas remain virtually unseen and unexplored by human eyes. This naturally feeds the imagination and the feeling that there must be secrets locked away, contributing to the narrative that we aren't being told the full story, even if the reasons are often practical and scientific rather than sinister. And as the world warms, some of Antarctica's longest-held secrets are beginning to emerge, whether we're ready for them or not. The most profound change happening in Antarctica right now, and the one revealing its secrets at an accelerating pace, is driven by global climate change. While the vast East Antarctic ice sheet remains relatively stable for now, the Antarctic Peninsula and parts of West Antarctica are among the fastest warming regions on the planet. Glaciers are retreating, ice shelves are thinning and collapsing, and this process of thawing is literally uncovering pieces of the continent's hidden past and present. As glaciers pull back, they expose land that hasn't seen sunlight for thousands, sometimes millions of years. This is a boon for geologists and paleontologists. New rock formations are revealed, offering clues to the continent's geological history and its connections to other landmasses within the ancient supercontinent Gondwana. Previously inaccessible fossil beds might become exposed, potentially yielding more evidence of Antarctica's surprising green past, new species of plants, dinosaurs, or mammals that could rewrite our understanding of life's history on the continent. Recently, melting has revealed ancient moss beds on the peninsula that were buried during the Little Ice Age centuries ago, providing snapshots of past vegetation changes. The melting also impacts those hidden systems beneath the ice. Increased surface meltwater can drain down through crevasses, reaching the base of the ice sheet and potentially lubricating its flow, accelerating the movement of glaciers towards the sea. Studying how the ice sheet is responding to current warming gives scientists crucial insights into how it behaved during past warm periods in Earth's history, helping them refine models of future sea level rise, one of the most critical questions facing humanity. The disintegration of ice shelves like the Larsen B shelf, which dramatically collapsed in 2002, not only contributes to sea level rise but also opens up previously inaccessible areas of the seabed for study, potentially revealing new ecosystems or geological features. So, while the melting of Antarctica's ice is a source of profound global concern due to its impact on sea levels and climate patterns, it's also paradoxically accelerating the pace of discovery. The continent is reluctantly giving up its secrets as the ice retreats. What ancient landscapes, lost ecosystems, or geological anomalies will emerge from the thaw in the coming decades? Antarctica, under the influence of a warming world, is perhaps entering its most revealing chapter yet, confirming that its story is far from static and that much of what it holds remains unseen.